Good afternoon, fellow countrymen. And this is Sivakumar from IIF Chennai Chapter Secretary. And before we start the presentation, I request everyone to put yourself on the mute. And so that we can get better focus for the presenters. It gives me immense pleasure to interact with you for yet another webinar, which is being seriously conducted by the Chennai chapter. And today we have a very important topic, which is called Importance of Energy Audit and Benefits for the Foundries by Mr. Dr. R. Sivakumar. He is doing for our last month also, we have conducted the webinar. In line with that, it's our series 2. And I'm sure that everyone would accept any process we put in place unless we do the continuous audit and we don't reap benefit out of it. I think we will touch upon in detail about energy audit and give us a benefit. And I would now request our chapter chairman, Mr. D.K. Ramans, to formally welcome the gathering, please. Sir.
Okay. Thank you, Sandhil.
Yes, sir.
Sandhil, am I audible?
Yes, sir, you are audible, sir.
Sivakumar, sir, good afternoon.
Good afternoon, sir.
So it's our immense pleasure to welcome you all for this another webinar to be presented by Mr. Dr. R. Sivakumar today. 2 weeks back, he talked about how the energy can be energy consumption can be controlled, and there are the packets available to take action on that. So today he is going to talk about the audit point, where always the audit outcome will give better results to focus where the energy is consumed more or where the energy is wasted. So in that context, today's webinar is going to be. I again welcome Dr. Sivakumar, energy consultant and a BE certified energy auditor for this wonderful gathering, and I request him to enhance our knowledge on audit points of energy so that all fellow foundrymen get benefited on that. Again, welcome all foundrymen and Dr. Sivakumar for this webinar. Over to Sindhil now. Thank you.
Thank you, sir. See, I think before we get into any subject, we need to also understand whom we are listening from. I think today's speaker may not require a big introduction, but as a formality, we would like to do the introduction. And Dr. R. Sivakumar is a Certified Energy Auditor by Bureau of Energy Efficiency. And he was worked as a cluster leader at Coimbatore for GF UNIDO B project on promoting energy efficiency and renewable energy in selected MSME clusters in India from July 2014 to December 2022. Presently, he is engaged as a cluster coordinator for UNDP Deloitte project on low carbon technology deployment in secondary steel units in Coimbatore and Palakkad clusters. They've got about 25 years of field experience in plant maintenance, projects, energy conservation, energy efficiency training and commissioning, etc. And he writes a lot of energy conservation and energy efficiency articles in many international and national conferences and workshops. And he educates and trains the engineering college students and faculties in the field of energy management and energy conservation. Actually, he served various positions in the industries: DuPont India Private Limited, Precol Limited, MMG India Private Limited, and Coimbatore Institute of Engineering and Technologies. And he has so far submitted 70 detailed project reports prepared and submitted, and 200 energy efficiency projects implemented through the project, around 30 lakh kilowatts saved per annum. He has conducted close about 40 workshops, organized nearly about 1,200 members in the cluster. And he also done close to about 60 detailed energy audits in sectors like foundries, pump manufacturing, textiles, papers, etc. And he is also member of IIF and life member of Society of Energy Engineers and Managers and membership with ISTE. Dr. Sivakumar, sir, the forum is yours.
Okay, sir. Thank you, sir. Thank you, sir.
Okay.
So good afternoon, one and all present here. First of all, I thank IIF Chennai Chapter for inviting me to give a presentation on importance of energy audit and benefits for Foundries. So I would like to thank Mr. V.K. Raman, Chairman, and P. Senthilkumar, Honorary Secretary, and other office bearers and staffs of IIF for inviting me to give this presentation. So last webinar in the month of November, we are discussing about the importance of energy conservation and the energy efficiency measures in industries. The continuation is the second phase is what is the importance of energy audit and the benefits for Foundries. So the slide is moved, sir.
Yes, sir. Yes, sir.
Okay, so today agenda is energy. What is the need of energy audit and the focus in energy auditing in air compressors and IoT based IoT is Internet of Things based the air compressor monitoring system and the energy performance of the foundry unit and some of the case study taken from our own energy audit along with the energy conservation proposals submitted to the industry. So the first topic is the energy audit. So already SAR says it is the right time to see the performance of the unit by while conducting the energy audit, then only know the industry where they are lying. So for example, mostly the industries are taken the specific energy consumption for liquid metal in the foundry sector above 650 or 630 and above only. Some units are taking around 750 and above also. But theoretically, the energy required for melting 1 tonnage of iron at the rate of 1500 degree, it needs only 395 units only. But practically, it ends up around 580 to 600. So many of the foundries are lying in between 600 to 630, 640. But most of the industries are beyond the limit only due to this various factor like raw materials and the charging pattern and the power setting. All those things are involved. So today we will discuss about the first thing is the need of energy audit and what is the benefits due to this energy audit to the industry, foundry industry. So basically the energy audit, what is meant by energy audit? It is a purely technical survey to analyzing the existing energy use, pinpoint the areas of wastages and to evolve energy saving scheme. So actually in India, the Energy Conservation Act 2001 was formulated by Bureau of Energy Efficiency. It is a nodal agency of under Ministry of Power. So the Bureau of Energy Efficiency only the nodal agency for in India for taking care of this energy all the things. So Energy Conservation Act 2001 was formulated by BEE in the year 2001. So the definition of energy audit means the verification, monitoring, and analysis of use of energy, including submission of technical report, it containing the recommendations for improving the energy efficiency with the cost-benefit analysis and an action plan to reduce the energy consumption. This is the energy audit definition. So basically in energy audit, we have to find out, monitor, and analyzing the existing energy performance, and the outcome of the audit will be given the suggestions wherever the improvement can be done with the help of best operating practices and some higher end energy efficiency technologies and some best practices to be adapted in the melting and other areas like auxiliary loads, so that the based on the analysis of use of energy, the technical report, that is the energy audit report, it containing the various recommendations, energy conservation proposals, along with the cost benefit analysis. For any investment, it needs some payback period. That's all. So suppose any energy auditing firm were taking the energy audit in a foundry, they are observing and analyzing for 3 to 4 days in a detailed energy audit. Based on the energy audit outcome, there will give recommended some 10 energy conservation proposal, means all the energy conservation proposal, each and every 10 energy conservation proposal will be elaborately, detailedly explained in the report. So what is the observation, what is the recommendations, what is the existing energy consumption in the particular area, and whatever the best practices can be done. All those things will be included in the report. Okay. So the report will be containing the cost benefit also, cost benefit analysis, that is simple payback period is also to be included along with the action plan to reduce the energy consumption to be reported. So this is the basic definition of energy audit. So it is an organized and systematic exercise with the top management support. Actually, the energy audit begins with the key decision makers, that is a top level management, and then involves slowly to the middle management, every employee on a day-to-day basis. This is the basically the energy management. If any corporate industry or any foundry industry was doing well in the energy, means it is a day-to-day process to be done for the energy management as well as the energy conservation activity. So basically this diagram, see, there are some set of input energy was given into the plant, and some useful output energy was served for the producing the product, and some losses are there. So in the energy audit, for example, in the case of foundry, some X units was consumed in the grid. So some liquid metal and the good casting output is taken as a casting output. So whether the proper optimistic energy can be used or not, or where the losses is going on. So the energy audit team main focus is where the losses is there. So we have to identify the various losses associated in the energy consumption. So the report containing all the energy conservation activities and the energy conservation proposal to be identified to the top management to reduce the energy consumption. So the energy audit addresses the scope of energy saving opportunities and operational improvement, and any retrofits or any new capital investment for new equipment, and some new technologies. Nowadays, mostly energy efficient technologies, devices are available, equipments are available. So any old running machines, it can be replaced with the energy efficient. For example, mostly in many cases, even in a small foundry, they're using the reciprocating air compressors. It is a very inefficient. So the kilowatt per CFM is very high. So they can replace with the energy efficient air compressor with the screw compressor. Nowadays it is come with the IPM model, internal permanent magnet motor. It will give more energy saving, and so that the payback period is very less. So the benefits of energy audit is identify the energy saving potential and the technology upgradation. Based on the energy audit, the unit can be saved around 10 to 20% of the energy saving possibilities is there. And the internal benchmarking, main thing is internal benchmarking, whether the particular foundry unit is taking the specific energy consumption within the benchmarking level, how the level is deviating from the benchmarking. So the energy auditing will give the more focusing on these are the various points in the energy audit. So these are the various energy audit steps. First, during the energy audit, we will visit the plant, foundry, or any industry. So we will understand the process study. Then data collection like energy production and the details are collected. And then we submit the energy audit offer. Based on the purchase order, we will go with some energy study with EMC instruments. Then we will plan for the detailed energy audit. So when we are doing the detailed energy audit, we are carrying some energy measurement instruments, that is EMC instruments. So we will do some 3 to 4 days, depends on the plant size. The number of days will be varied. For a small unit means 1 or 2 days is sufficient. Bigger foundry or bigger unit means it needs maybe 1 week also. So during the audit period, we will identify the various energy saving potential areas. Then once the audit is completed, we will come back and we prepare the report submission, the energy audit report. In the report, we will give the technology suppliers recommendations is also included. Then the final report will be submitted and the observations are discussed with the top management. These are the various steps followed in the energy audits. So basically, the energy thing is how the benchmarking means what, how to measure the performance, and the grades, how to measure the performance in the mileage. In the two cases, first thing, for any student, the performance measurement for any college student or school student is only grade. So how much grade or how much percentage they secure. So that is the performance measurement of a student. Similarly, for performance measurement of any car, it will be give out ultimately mileage, how many kilometers will deliver per liter of petrol or diesel. This is the benchmarking level. Similarly, in all industries, there are some benchmarking level is there. So the parameters to track energy related performance of the industry, there are two major indicators. One is total energy consumption and the specific energy consumption. So the total energy consumption In the detailed energy audit, what we will do is we will do the energy balance and the material balance. Mainly, we do the energy balance. In the energy balance, what we will take it into account means in the case of foundry, for producing the final casting, mainly they are depending on the grid energy, EB, electricity board, for the induction based furnaces. Suppose if it is a cupola furnace, means they are using coke. So the coke is the main raw material, main energy sources for the cupola furnace based industry. So we will accounting the energy we have taken from the EB grid plus any LPG cylinders is used for cutting process, and diesel is used for including process as well as any power cuts they are using for the running the generator. And any other fuel like for ladle preheating, they are using furnace oil or any LPG gases is used. So whatever the energy used within the premises, all the things are accounted, so that we will converting into the energy balance sheet. So the total energy consumption will be normally accounted into terms of TOE, is called as a tonnage of oil equivalent. So each and every fuel having its own calorific value. Already this matter was discussed in the last webinar also. So for consuming 1 unit of electricity, it is equal to 860 kilocalories. Similarly, consumption of 1 liter of diesel, that is LDO, is a light diesel oil. Oil is equivalent to 9,700 kilocalories, and for LPG also 1 kg of LPG is equivalent to 12,500 kilocalories. For cupola based foundry units, the coal consumption is there. So the coke consumption calorific values is also varied from party to party, because the coke is where it is taken from Indonesian or any Australian or any African coal it is prepared. So this value to be get it from the supplier. So the supplier will be responsible to give the calorific value. So we are taken into account for all this thing for at least for 1 year. So it will be converted into tonnage of oil equivalent. See here, this is an example. In the particular company, the plant, it consumes 4,70,814 kilowatt of grid electricity per year, and 1,107,78 liters of diesel. So these are the two dominant fuel used for the production activity. So it is converted into equivalent kilocalorific value. So the total kilocalorific value is somewhere 1392146,640 kilocalories. It will be converted into tonnage of oil equivalent. Tonnage of oil equivalent is nothing but 10 power 7 kilocalories equal to 1 tonnage of oil equivalent. Here we can divide it by 10 power 7, 10 to the power of 7. It will give 139.21 tonnage of oil equivalent energy was consumed by the particular industry. Similarly, in a foundry, so for last 1 year, what is the electricity consumption? What is the diesel consumption, LPG consumption? Even sometimes furnace oil is used for ladle preheating, and any firewood is used for heating purpose or any other purpose. All the fuel is converted into calorific value. Then finally, it is taken into oil equivalent. Okay, this is the energy balance. From the energy balance, we can accounting the various losses associated in the process. So here, there is a graph is there. Hello?
So some noise is coming, sir.
Yeah, yeah.
Echo from your end, sir? Or?
No, sir, no, sir. From any one of the user.
Okay, I think requesting every members to put yourself mute.
Mute, yeah.
Yeah. Please, sir, please continue.
Yeah, here there is one graph is shown. It's a bar graph. So the month wise varies with the total energy consumption. So here January to December, it's shown some various electricity consumption month wise, but it is not provided true picture to the industry, because here there is no production activities there. So if the increase in the total energy consumption can be due to increase in production also. So the production quantity is not captured in this indicator. So not only we take the energy consumption is not a good indicator of any industry, any process industry. So we have to correlate with the energy versus production also. So some of the benchmarking parameters followed in the industry for gross production related. For example, kilowatt hour per metric ton of cement produced for the cement plant is the internal benchmarking. Earlier, the cement manufacturing plant, they consumed nearly 2000 units per ton. Now it is reduced due to this various technology adapted and energy efficient measures in the cement industry. It will comes around 600 to 700 units of kilowatt per ton. So that much drastic changes was happened in the cement industry. Similarly, for our foundry units, the benchmarking is kWh per metric ton of liquid metal or kWh metric ton of good casting. Equally, most of the foundries are taken the kilowatt per metric ton of auxiliary loads is also there taken into account. Similarly, for paper produced is kWh per metric ton or kilocalories per kg of paper produced. And for the fertilizer plant and million kilocalories per metric ton of urea or ammonia produced. Similarly, for the power plant, the thermal power plant, mainly they are taken into account kilocalorie per kWh of power produced. That means for producing 1 unit of electricity, how much kilocalories they consume. That is the benchmarking for the power plant parameter. Similarly, for the small equipment related, the benchmarking parameter will be kilowatt hour tonnage of refrigeration for the air conditioning plant. For AC measurement, how much kWh, that is unit consumption per TR, is the rated parameter for benchmarking parameter. And kWh per Nm meter cube is a normal meter cube for the compressed air generator, but practically we are seen as telling us CFM, that is a cubic foot per minute. So kWh per CFM is also now in most of the industries following these practices only for the compressor air. And another classic example for the DG sets, how many units was generated per liter? It is called as a UPL. UPL means units per liter, nothing but kWh per liter. So second thing is the energy study in air compressor, because in air compressors it's mostly in all the foundry units they are used. So during the energy study, energy audit, what are the points we measured in the air compressor we will address. So here, this is the Sankey diagram. So the Sankey diagram says what is the input and what is the output, how much energy was usefully converted as a air, remaining is converted as a loss only. So here there is a small blue layer is in that bottom area you see in the Sankey diagram. That is the delivered compressed air. That means only hardly 10% of the input energy will be converted into compressed air. Remaining 85 to 90% of the energy was wasted in the generation, transmission, and treatment, other hot areas. The other areas, the wastages was generated from the input energy. Only whatever the input energy is given in the compressor, it was converted only 10 to 15% only. The useful air was generated. For example, a 100 HP air compressor, that is a 75 kilowatt air compressor is there. But normally, based on the service factor, the compressor will draw around 105 to 110 kilowatt per hour. So out of this 110 kilowatt hour, only 10% of the input energy was converted into air, remaining all wasted as losses. So in compressor, because normally the mantra told air is free, but the compressor air is not free. So because the air compressor air is very, very expensive, because we are using motors from converting from the electrical energy into mechanical energy. So the mechanical energy, pistons and other engine elements was converting the compressed air. So there are a lot of conversion activities going on in the air compressor, so that the compressor is a very, very least efficient equipment, so that we will very cautious by using this air compressor. Mostly it was used for misusing for human body cleaning in most of the industry. It can be avoided. So the air leakages is also minimized. So there are a lot of potentials are there in the air compressor area. So air compressor is very, very expensive, and up to 20 to 30% of the energy savings possible by simple maintenance measure itself and air leakage errors at regular interval. You can save around 20 to 30% of the energy efficiency. And the FAD is a free air delivery. The FAD can be increased up to 12% by cleaning the inlet and outlet air filters. So as per our foundry schedule, this was followed from many corporate industries. They are following the maintenance schedule, TPM schedule. So every day they open and they clean the inlet and outlet air filters. So it should be followed at regular interval. So every 4 degree suction point, the air intake is reduced by the ambient 4 degree, it will lead to 1% of the energy consumption. But practically what happens means in the ambient to above 6 to 7 degree, some cases 10 to 12 degree was increased in the compressed area. So it will lead to more energy consumption in the air compressor. So this is the typical compressed air system layout. So nowadays it is followed with the complete ring main system. So the generation compressor is there, then the second, the primary filter is there. After this primary filter, there is the air receiver. After receiver, pre-filter is there. Before dryer, so air dryer is drying all the moisture component. Then the dry air will be going to the outlet area. So there are so many filters elements is there. So in the distribution area, the ring main system will help the pressure drop and the pressure losses is also reduced, and so that your compressor efficiency was increased. So your compressor energy consumption is also reduced such a way. So this is a complete ring main system structure. So during the performance assessment of the air compressor, these are the basic instruments we need. Power quality analyzers or energy meter. Mostly today the industries are adapting the multifunction energy meter in the every equipment, so that we can take in the reading in the energy meter itself. No need not to bring the power quality analyzer. But during our energy audit program, we are taking the power quality analyzer to log in the air compressor to take the performance study for 1 hour or 2 hours, depends on the size and usage of air in the foundry. And the pressure gauge, already the pressure gauge was also mounted in the air compressor, anemometer, IR thermometer, and ultrasonic leak detector. So the ultrasonic leak detector is a special type of instrument. It will identify the wherever the air leakages is there. Normally during the foundry operations, running operation, we cannot be able to detect with our human ear. The air leakages cannot be detected. So mostly many of the foundry units are following these practices during the lunch time, or only in the Sunday they are conducting the leakage study. In the leakage study only, they will know where are the air leakages are there. Then they immediately rectify the air leakages. This is the regular practice. But this ultrasonic flow meter, even the foundry is running now, so we can be able to identify the air leakages, and some advanced instruments are available. How much CFM was leakage in the particular point, that is also can be driven from the ultrasonic leak detector. So some of the best practices followed in the air compressor: set the optimum pressure, 1 bar reduction, it will give 6 to 8% of energy saving. But mostly many of the industry, not only foundry, whenever we are going for any industry for energy audit, the set pressure and the loading and unloading set pressure is a maximum limit only. They keep on because of some flexibility. They don't want to have some issues with the compressor. That's why they safely set in the maximum level. For example, 6 to 6.5 kg pressure is sufficient for the air compressor, is sufficient for the inside operations of the foundry operations. But the plant setting, we found the loading pressure is 7.5 and the unloading pressure is 8.5. Even 0.5 kg reduction or 0.5 bar reduction in the pressure bandwidth, we can save around 3 to 4% can be saved directly. And mostly in the screw compressors, no, the loading and the unloading condition we can taken from the directly from the running hours and the loading hours itself. It will give the picture of unloading condition, unloading time and the loading time. So if the compressor is unloaded for more than 30% or 25%, better the VFD option can be adapted so that the unloaded power can be saved. So normally the loading and unloading time, the unloading time, if it is exceeded more than 25 to 30%, means we can adapting the VFD is the best choice. And the second thing is, earlier I discussed, no, the air intake must be very cool. 4 degree reduction, it will give 1% of the energy saving can be done. So the compressor position and the room and the environment ambient is also very clean, should be maintained in the air compressor. And clean the air filters at regular interval. Similarly, replace the oil filters at regular interval as per the OEM recommendations, and avoid cleaning with the compressed air, and use portable blowers wherever it is possible for cleaning purpose. and optimizing the cleaning pressure as 2 kg per centimeter square. So in every audit, we are recommended the cleaning pressure to be maintained between 2 to 3 kg only. But practically what happened means the same line pressure generated from the air compressor, whatever the pressure was received from the receiver, 6 kg up to 7 kg or 8 kg, the same pressure was used for cleaning. So it can be reduced to 2 to 3 kg. And replace the energy efficient, replace with the energy efficient screw compressor from reciprocating. If the reciprocating compressor is running for more than 20 hours, 20 years or 25 years, it can be replaced with the screw compressors can be replaced. So energy can be saved. And VFD can be implemented for above 30 HP air compressors, and the loading and unloading is very variation is there, more than 25 to 30%. Unloading is there. VFD option is the best option. And the ring main system reduces the air loss. Use small compressor if major production load is off. It is particularly used for Sunday. For any Sunday, maintenance activities going on. During that time, need not to run the bigger compressor. During that time, one 5 HP compressor is there. The 5 HP compressor is used for the maintenance activities. And use drain controls. Normally, the receiver should be contain the auto drain valve to be provided. And the leakage study to be conducted at regular intervals. So it will give more energy savings. So it should be practiced at the regular interval, and preventive and predictive maintenance to be carried out also regular interval. So these are the best practice, various practices in compressed air system. Then how to arrive the specific energy consumption. For 50 HP screw compressor deliver 200 CFM at the rate of 8 bar with a service factor of 1.15. Service factor means the OEM was designed the compressor motor is taking another 10 to 15% extra power to withstand the that much pressure, so that every manufacturer was given, and it was mentioned in the nameplate of the motor itself. Few manufacturers given is 1.2, some manufacturers given 1.1 to 1.15. So here the energy consumption per hour at 100% loading means 50 HP is equal to 37 kilowatt. That means 37 kilowatt into service factor 1.15 divided by the delivered CFM is, we think the compressor is generating 200 CFM assumption. That means 37 into 1.15 divided by 200 equal to 0.212 kilowatt per CFM. This is the benchmarking of the compressor as per the design. Whether this design parameter is achieved or not, we can see in the practical only. See, in this case, if the compressor is running for 70% loading time and 30% for unloading time, means the energy consumption will be 0.7 into 32 plus 0.3 into 14, because this 32 is during the loading time, the compressor is taken 32 units, and during unloading time, the compressor taking 14 units. That means 70% is the loading time and 30% is unloading, means in an hour it consumes nearly 26.6 units. So we don't have any flow meter mechanism in the compressor in the existing system, so that we cannot be able to know how much CFM will be generated. Suppose any IoT monitoring device, flow sensor is there, we can able to monitor during this period how much CFM the compressor is generated. Based on that, we can put it the CFM value in the denominator, so that 26.6 divided by the CFM value, it will give the correct benchmarking data. In later part, we can see how the IoT system will help to monitor the compressor performance. So power reduction through some pressure reduction. So already it was discussed. So every 1 bar reduction will give 6 to 8% of energy saving. So the in the first column, average load in kilowatt for 4 kilowatt, 7.5 kilowatt, 11 and 15 is the kilowatt. In the first row, it represents the air pressure reduction from 0.5 bar, 1 bar, 1.5 bar and 2 bar. So how much energy savings is there in the second, third and fourth column it represents. For example, 4 kilowatt compressor, if the 0.5 bar reduction in the pressure, it will give 320 units savings per year. Same 4 kilowatt, 1 bar reduction will give 640 units, 1.5 bar reduction 960 units, and 2 bar reduction will give 1280 units. Similarly, for 15 kilowatt compressor, if the pressure is reduced to 1 bar, it can be saved 2390 units per year. Same time, 2 bar reduction will give 4780. So in here, there is no investment is needed. So that's why the compressor pressure band will be optimized in the industry, So whatever the process demand requirement, based on that, the compressor pressure band to be fixed. Otherwise, we are losing more energy. So this chart will depict the various energy losses associated with the due to this high pressure setting. So this is the pipe sizing. Pipe sizing is also very, very important. See, normally for 200 CFM compressor means minimum 2 inches to be provided. Similarly, for 300 CFM means 3 inches to be provided. So how much CFM the compressor generation capacity? So that much inches to be provided for the air pipeline. This is the basic thumb rule. For 400 CFM also 3 to 3.5 inches. For 500 CFM 4 inches pipeline to be needed. So the pipeline size is increasing. There is a no pressure loss is there. So this picture will depict the pipe sizes is increasing. No, your power consumption is loss is also reduced. That is ultimately that much kilowatt will be losing. In the second slide, we can see the energy wastages due to smaller pipe diameter. For nominal bore size 40 mm bore size at the rate of pressure drop is 1.8 bar for every 100 meter. It is equivalent to 9.5 units were lost. Similarly, for the same kind of generation, 80 mm pipe is used means the pressure drop is only 0.04 bar only. Here 40 mm is 1.8 bar. 80 mm means 0.04 bar. That much pressure loss will be reduced in the pipe sizing is increasing, and equal to power loss is also only 0.92 instead of 9.5. So 100 mm bore size means the energy loss is 0.1 kilowatt and the pressure drop is 0.02. So typical acceptable pressure drop in any industrial practice is 0.3 bar to 0.2 to 3 bar in the generation side. And the tail point, that is the farthest point of the industry, is 0.5 bar. That means you have some 3 or 4 multiple compressors in the compressor generation system. There is a final air dryer and the receiver is there. You can see the output of the air dryer and the air receiver. What is the generation pressure? For example, 7.5 is the air generation pressure. In the air dryer, output should be 0.2 to 0.3 bar only reduction is there. If it is more than 0.5 or 0.6 bar, there is a huge scope of energy saving possibilities there, because there are some maintenance activities to be done. From the generation side is also we are losing. The pressure drop is 0.5 to 1 bar means it is very, very critical, alarming. And the same thing, the air is given to the process side. If it is the proper ring main system is adapted in the foundry, you can see the farthest point, distance point of the foundry unit. You can see what is the pressure drop. So the farthest point should be around 0.5 bar and the generation side should be 0.2 to 0.3 bar. This is the standard followed, but during our audit, these are the measurements we are now doing. So, and the air leakages, due to this air leakages, how much energy we can save. See, here there is a percentage of air leakage, T divided by capital T plus small t. This small capital T denotes the loading time in seconds, and the small t denoting the unloading time in seconds. Normally, this compressor leakage study to be conducted in the shutdown time only. Normally, ideal period is the national holiday or Sunday is the preferable time. So during that time, the machines should not run. So the moment the compressor is the air receiver and all those things are emptied. So now there is no air in the premises, in the air receiver and other area. Just to close the outlet of the air receiver. That means the air receiver output valve to be closed. Then the air compressor should be run. Then immediately stop by using this stopwatch. Take the loading time. How much time the receiver takes for filling the air? How much time it is take? So that is the T, capital T. Once the receiver fill, then the compressor is going for the unloading mode. Okay. Then after the some preset time, the compressor should off. Okay. Now you can open the outlet valve of the air receiver. Now the air is going into the plant. So all the machinery inlet to be opened. Okay. Only machines should not used. So based on the air leakage, again the compressor is getting loaded. So we can note down this loading and unloading time for at least some 10 to 12 cycles for taking better accuracy. Based on that, you can apply this value. Then the percentage of the leakage will give some quantity of air leakage. Okay, and the leak hole size now. For every 1 mm of hole leakages at the rate of 8 bar, it loses 75 liters per minute. For 3 mm hole, it loses 600 liters per minute, and its equivalent energy loss is 4.4 units, and here to 1 mm means 0.6 units, and the rate of cost is equivalent to 34,560, here 2,53,440 for single leakage, for single 3 mm leakage at the rate of 8 bar pressure. We are losing around 2,53,440 rupees in a year. So consider this is the assumption. Operating pressure is 8 bar, operating hour is almost 7,200 hours in a year. So here I come to my project. So one of the foundry, they adapted the state-of-the-art energy efficient air compressor system. This was implemented through our project. So we are given almost 40% of the implementation cost to the foundry unit for the encouraging the unit for implementing the energy efficient technologies. See here, there is in the existing system, there are 90 HP was adapted in the air compressor. That is 150 HP and 40 HP. Both the compressor is running for almost 16 hours, and one single compressor is running for 6 to 8 hours in the night timing only. And both the compressors are screw compressor only. The existing energy consumption is around 870 units per day. Now we are suggested to change with this 90 HP with a single 60 HP compressor inbuilt with VSD, that is the variable speed drive. This compressor is the internal permanent magnet motor technology adapter. So this manufacturer is in Coimbatore only, both air compressor. So now it is implemented with the 60 HP screw compressor, IPM model, inbuilt variable speed drive. So now the present energy consumption is 630 units. Almost 240 units was saved in a day. So other things we changed, the complete air dryer is also earlier it is not work, that is also replaced, and one more 4,000 liters of air receiver was installed in the generation station. So here the existing operating pressure is 7.5 bar to 8.5 bar. The new operating pressure band is 6.3 bar to 7.5 bar. So that's why the average energy consumption is down to 870 to 630. So this is the representation. So in a month, they can be able to save almost 5925 units was saved. If you are comparing with the specific energy consumption for liquid metals, earlier is 50.1 kWh per tonnage of liquid metal. Now it is only 29 only. So 21 units of was saved for every liquid metals production, tonnage of liquid metals. So these are the other things. The existing receiver is 2111. So totally 5 KL of receiver is there. Now it is 4,000, 1,000. So almost 7,000 liters receivers was adapted. So the overall investment cost is 15.15 lakhs. The energy saving per annum is 71,100 rupees. The approximate cost saving at the rate of 8 rupees is 5.7 lakhs rupees. So that the payback period will be 32 months. So due to this adaptation, the unit can be saved 71,100 units of electricity was saved. That is equivalent of 6.10 tonnage of oil equivalent. Already I told that means 71100 into 860 divided by 10 power 7. It will give 6.1 tonnage of oil equivalent. And CO2 reduction is also 59.25 metric tons. So ultimate aim of any energy audit is how much CO2 to be mitigated from the energy efficiency and the energy conservation. So due to this energy efficiency measure, the foundry units was saved, and MTO 6.1 tonnage of oil equivalent was saved, and 59.25 tons of metric tons of CO2 emissions is also reduced. And the other case study is, during our energy study, we suggested to replace with screw compressor with VFD. The existing one is 40 HP screw compressor. It was replaced with 30 HP screw compressor with inbuilt VFD, because the old compressor is almost 15 years old and the efficiency is very less. So that's why we suggested. So after this, the unit was consumption is only 500. Nearly 210 units was saved with the new air compressor. Sir, so far the PPT was visible, sir?
Yes, sir.
Yeah, okay, sir. So this is the benefit. So
It's
earlier,
not in the presentation mode. It is not in the presentation mode.
okay, sir. Now it is presentation mode. Hello?
No, sir.
Hello?
No, sir. No, sir. Still, I'm getting left-hand side. Your other slides are visible.
Okay. Okay, here the full PowerPoint presentation is not able to view, sir. That's why.
Okay, okay. Not an issue. Not an issue. Continue.
Okay, sir. So the summary of the implementation, no, existing 40 HP was replaced with the 30 HP. So every day 210 units was saved, and in a year, nearly 65,520 units was saved, and cost saving is 4,91,400, and the capital investment is 4.5 lakhs. The reduction of the payback period is only 11 months only for the implementation. So another only example is replacing with the screw compressor. The old system, they adapted 15 HP reciprocating compressor 5 numbers and 130 HP screw compressors is adapted. It was all are replaced with 60 HP 45 kilowatt with inbuilt VFD compressor. So the energy saving per month is almost 11,536 units. So in a year, 1,38,000 units was saved, and the approximate cost saving is nearly 11.04 lakhs, and the investment cost is 10 lakhs. The payback period is also 11 months. And pressure optimization, these are the very smaller, there is a no investment because it is the best operating practices. During the study in one of the small foundry, we seen the pressure band setting is 8.5 bar is the loading and 9.5 bar is the unloading. So we are forcefully reduced the pressure band to 7 to 8 bar. So in the existing system, the compressor, because the compressor capacity is only 15 HP only, 15 HP is 11 kilowatt only. So here, the current taken by the existing setup, 21.6 ampere is taken at the rate of 9.2 to 9.3 bar. Now, after this pressure band reduction, at the rate of 8 bar, the compressor is taking only 18.6. That means 3 amperage will be reduced. So 3 amperage means the power reduction is √3 VLIL cost rate. So almost 13 units was saved in a day, because this particular industry was running for only 12 to 14 hours per day only. So average energy saving per day is 13 units. In a year, 4,050 units was saved, and the approximate cost saving is 30,420. Here there is a no investment, only the pressure band was reduced. So the payback is very immediate. And similar kind of same exercise was done in another industry also. Here the loading and unloading pressure point is 8 bar to 10 bar. That was reduced to 7 to 8 bar. So in the existing system, the compressor was consumed 13.31 units. After this pressure reduction, 10.56 units. So the unit can be saved around 30 units per day. In a year, 9,360 units was saved, and 65,520 unit cost was saved in a year. And the payback period is immediate because there is no investment. And one more unit is having 2 compressor, and only 1 compressor is running at a time. So we suggested to implement one common VFD for both the compressor. So the unit was saved around 73 units per day, because this unit is also running for 16 to 18 hours in a day only. So in a year, they saved 21,600 units. Cost saving is 1.62 lakhs. The investment cost is 1.2 lakhs. The payback period is 9 months. And another foundry, they're having 100 HP, that is a 75 kilowatt screw compressor is there. During our energy study, we observed 65% is the loading and 35% is the unloading. So we suggested to the industry to provide the VFD. Then after this VFD implementation, the unit was saved almost 360 units per day. So this is the energy consumption pattern. In the existing system, the compressor drawn almost 148 amps in the input area. After the conversion, 65.34 units only it was consumed. See, after this conversion, the VFD implementation, the current rating is only 92 amps only. So the overall energy saving is in a year almost 90,000 units per year at the rate of 300 days working day. So approximate cost saving is 6.75 lakhs. The investment cost is 2.6 lakhs. The payback period is only 5 months. This project is actually implemented in the year of 2017 end. Still the VFD is running with the good conditions. So another one important example, in one of the pump industry, they are having captive foundry along with the pump industry. For this pump, coil forming machine, no, there is pressure, there is a cylinder is there. So the pneumatic air is required almost 9 bar pressure, 9 kg pressure is required. So due to this reason, the compressor head was trimmed and it was generation pressure is raised to 11 to 12 bar pressure in the generation. But other area, except this coil forming machine, other areas needed only 6 to 6.5 bar pressure. So we suggested to adapt a air booster in the particular equipment. So the air booster principle is whatever the input is given, it is amplified into 2 times. So the total air generation pressure was reduced. So this coil forming machine now, 2 coil forming machine is operated with the help of this air booster. See, this is the air booster diagram, the picture. In the air booster itself, there are some 50-liter reservoir capacity is there. So after adapting this air booster, the pressure generation is reduced to 7 bar. So due to this, the unit was saved almost 7,200 units per day, per year, and the cost saving is 50,400 rupees, and the investment cost is 50,000. So the payback period is will be excellent. So this is the inlet pressure, this is the outlet pressure. So inlet pressure is 5 bar, outlet pressure is 10 bar. If this inlet pressure is given to the air booster generating 10 bar. This 10 bar is used for the coil forming machines. So far we see some of the auditing point and best operating practices in the air compressor. And the third topic is Internet of Things based energy monitoring systems in air compressor. So one of the startup company in Coimbatore, he is very much helpful during our energy audit. So we can able to find out what is the present CFM generated from the existing compressor, whether it is energy efficient or not, how much energy is lost, all the things we are able to monitor. So this is a general IoT monitoring system. So the figure 1 is represents, this mark 1 is the airflow sensor. They basically it's a mass flow thermal sensor. So it is a IMF IMD sensor. This is an imported sensor. This is operated based on the temperature difference principle. So whatever the air pressure and the CFMs are generated pre-air delivery, the airflow sensor captures the value and it is given to this IIoT, that is IoT device. And second one is to monitor the air pressure. There is a Danfoss process which is there. And the third one is the dew point measurement. There is one device is there. And fourth is the differential pressure. That is an inlet and outlet differential pressure. And finally, fifth one is the energy meter. Mostly this energy meter, if it is not available, means we put our power quality analyzer in the input of the air compressor so that we monitor the what is the pressure generation and what is the CFM output, and with respect to what is the unit consumption, so that we can arrive the kilowatt per CFM. And also the main thing is the same device, it can be used for measure the air leakages quantity also. Later on we see. So this is the system to be integrated in the existing pipe. This mass flow sensor will be adapted and the pressure can be adapted. This the second one. So this is the value 145. No, some values were shown as per the flow output. So it is given to that IoT controller device. It will be given. So based on this study, in 1/1 to 2021, 2, 3, 4, 5, some 5 days data we take for the 24 hours, the compressor was generated. The maximum CFM is 399 on first, and the minimum is 9.88. The average CFM is 220. The maximum kilowatt and the average kilowatt is 51.06 units per hour. So that the CFM rating, kilowatt, all these things can be monitored in the system, so that the unit can be able to understand whether the compressor is efficiently running or not. So normally it is advisable for more than 3 or 4 air compressors in the multiple air compressor used in a bigger plant, bigger foundry. This system will be very helpful for the industry, whether the compressor is running in the efficient manner or not. Similarly, for one of the foundry, we asked to this air study was done during the normal operation. It was studied from evening 5:15 to up to night 8:50. Every 0.07 minutes, the data are captured. So the maximum CFM generated in the compressor is 403, because here there are 2 air compressors running parallelly. Each 100 HP compressor was running. So the average CFM was generated from these 2 compressors is 344, and the minimum is 251, and total meter cube all these things are taken, and I put my power quality analyzer in the input so that we can arrive the kilowatt per CFM. And this is the trend mark in the graphical form. So the red color indicating the pressure level and green is indicating the CFM level. Suppose if the energy meter is also incorporated, then you can able to monitor the kW also. So you can able to visible pressure, CFM, that means airflow, as well as the energy consumption in the same manner. Same thing in the study line 1, what is the maximum and the minimum. So this is the air leakage study. See, the earlier one is the air leakage study in the same plan. During the times, almost some half an hour, the entire operation was stopped. So this indicated the pulse wave kind of waveform. No? This is the energy loss due to this air leakages. So we can put the power analyzer, means we can able to quantify how much kilowatt was lost due to this air leakage. So this tool will be helpful to the industry. So how much CFM air leakage is there? And if the kWh meter, energy meter is incorporated, unit can be exactly quantify the energy loss also in terms of CFM, in terms of kWh. Similarly, for air leakage study in the another line 2 in the same foundry. So this is the air leakage study. So here the line 2, the leakage is minimum, whereas line 1, the leakage is high. So far we see the energy performance assessment of the compressor and some of the IoT device-based monitoring system. So now we can see during the energy audit, we are arriving some energy performance of the unit. This is the typical one of the energy audit outcome of one of the foundry unit. So the energy was consolidated for almost April 21 to September 22, nearly 18 months data we can consolidate. Here, this foundry is used to only EB and the LPG and the HSD. This is the 3 fuel they are mainly used. So electricity consumption is almost 122.68 lakhs per year, and it is equivalent to 1055.08 tonnage of oil equivalent. How it is calculated? This quantity of electricity 122.68 lakhs into 860 divided by 10 power 7 gives 1055.08. LPG is 480. So this equivalent value is 12,500 kg per 12,500 kilocalorie per kg. So 480 into 12,500 divided by 10 power 7, it gives 4.32. And HSD is high speed diesel. Diesel is used for the backup power for the DG sets. The consumption is around 4,000 liter. So that 0.6 is the MTOE. So total oil equivalent is 1,060. Out of this 1,060, 99.5% for electricity, 0.1% for LPG, and 0.4% for the diesel. And the energy cost summary, the same quantity. This is the cost wise, 945.81 lakhs. And 3.4 lakhs and 0.54 lakhs. So 99.6 lakhs is 99.6% is accounting for EB and 0.36 for HSD and 0.04 for LPG. So this is the graphical representation. What is the energy share and what is the energy cost share? And here the liquid metal versus good casting summary. So October 21 to September 22, almost 1 year we have taken. So the average value. Here there is a blue line indicating the liquid metal and good casting production in terms of, sorry, this is the liquid metal production. Sorry, it's not a specific energy consumption. During this period, what is the specific energy consumption? Production rate of liquid metal versus good casting. And the specific energy consumption, average specific energy consumption for the liquid metal during this period is 677 units per ton. That is a 677 kWh per metric ton. And for good casting, 1,353 kWh per metric ton and 286 units per ton for the auxiliary loads. This is a specific energy consumption trend. And another foundry we can study with the 2 furnaces they are implemented. So here the sharing for the total energy consumption share now. For AB furnace 37% and the CD furnace 33%, remaining 30% for the auxiliary loads. And the same company, they are installing 750 kilowatt dual track furnace, and the furnace melting capacity is 1,000 kgs. So the power setting was almost 700 kilowatt plus 50 kilowatt, and the melting timing is 50 minutes. and the melt rate is 20.83 kgs per minute, and the tapping temperature ranges between 1480 to 1510 degree. And the specific energy consumption for liquid metal varies from 662 to 701 kWh per metric ton. So during the audit time, we are observing the following observations. The raw materials are properly weighted and added to the furnace. Before adding into the crucible of the furnace, the raw materials are properly weighed and it was noted down. It's a very good practices. And the scraps and the return size is more than 1/3. This is the one of the thing is wrong practices. Normally, the scrap and return, whatever the material poured inside the furnace should be 1/3 of the crucible diameter. So here there is above the 1/3 of the crucible diameter, the scrap and the return materials was poured, and mostly short blasted scrap materials were used as a raw material. This is also one of the good practices. Otherwise, the slag formation is more, and the CI boring is used between 5 to 10%. The average liquid metal taken is around, this is the 1 ton crucible output, so 1025 to 1050 kgs, and the capacity utilization is 85%. And the coil cooling raw water inlet temperature is 31 degree and the outlet is 51 degree. The tamping temperature is also around 1510 degree. These are the observations made during the melting energy study. And this is the energy versus production study. Totally 22 heats we continuously monitor with the power quality analyzer in the main input, the transformer primary. So 22 heats was studied for almost 1 day, 24 hours. So raw material charge is 23 tons, liquid metal output in kgs is 23 tons, poured metal is 22,253, good casting is 11,126 kg, yield is 48.4%, and the average pouring temperature is 1510 degree. Energy consumption is total 22 heat. It consumes almost 14,840 units. So specific energy consumption per liquid metal is 645.22 units per ton, and for the poured metal 666.88 units per ton, and for the good casting 1333.81. So this is the power quality analyzer reading. Here there is a date and timings there: 1/11/2022 5 p.m. to next day 2/11/22 3 p.m. Almost 22 hours the furnace was studied. So there are two services is there. Here there is an annual energy study. So there are two HT services are there in the same premises. So both services, what is the unit consumption? Total consumption is 122 lakhs 122.68 lakhs, and EB bill value in lakhs is 961.15 lakhs, both put together. And the sanction demand for each and every service is 1,350 and 1,300 kVA. What is the average and maximum? 90% of the sanction demand. Here they are using the green energy, wind energy, and IEX passage, and the solar is used. So what is the solar energy adjusted is from each service? What is the IEX third party power purchase? How much energy was adjusted in the wind? All are accounted. So the average power factor between these two services is 0.99 and 0.99. So average cost per unit, service 1 is 7.80, service 2 is 7.87. So the total service 7.83. So this is the general summary of the EB bill. So this is the renewable energy adjusted, wind energy, IEX passage, and solar energy. So from the main grid consumption, how much energy was adjusted through this green energy, that is renewable, like wind and IEX and solar. Here in the month of October 21, 86% was adjusted with the wind energy, and the November 71. And in the month of April, 32.6% of the energy was adjusted in the green energy, that is IEX, solar, and the wind. And the average energy for this period from October 21 to September 22 is 81.1. That means this foundry units was having green energy, maybe carbon neutral for the energy consumption. No, 81% of the grid energy consumption was adjusted through this green energy called solar, wind, and IEX. So there are two transformers are there. So transformer 1 load factor is 65.8. Transformer 2 load factor is 66.2%. So basically these are the various slides associated with the to monitor the performance assessment of the foundry unit. Then the next one is a case study and the energy audit report with the ENCON proposals. So here one of the foundry we are given almost three kind of energy conservation proposal we are splitted. One is zero cost investment. Here there is a no investment like pressure adjustments. No, earlier we discussed for the air compressor pressure band adjustment there is a no cost. This kind of performance is called as a zero cost investment, and the low cost investment is somewhere around less than 2 lakhs, and high cost investment is 2 to 5 lakhs. These are all called as a low cost and high cost. For the zero cost investment itself, the unit can be saved 1,64,316 units, and cost saving is 13.8 lakhs. So here there is a no investment is needed, immediate payback, and low cost investment 54,450 units can be saved, 4.55 lakhs units can be saved, and the equivalent cost saving is investment cost is 4.22 lakhs, and the approximate payback period is 1.1 year. And high cost investment is also the unit is needed 26 lakhs for investment. For 26 lakhs investment, the unit is able to achieve 13.9 lakhs of cost with 1,64,400 units was saved. So the payback is 1.88. So all put together, these three kind of proposals, the overall unit saving is 3,83,166 units, and 32.3 lakhs is the cost saving, 30.2 lakhs is the investment needed, and the approximate payback period is 1 year. So here there are some zero cost investment proposal. There is a 500 kVA transformer LT voltage regulation through optimize the tap position. So here there is a OLTC is not available. So it can be saved around 30,000 units can be saved. 2.52 lakhs rupees can be saved due to this measurement. And induction furnace power setting to 500 kilowatt, because due to this the unit was setting the power almost 450 to 430 to 450 units only set at. So if it is increasing to 500 kilowatt, the power melt rating is increased. So due to this melt rating is increased, the melt time duration is reduced, so that the energy consumption is energy conservation is there. So approximately 37,800 units was saved, and here also there is a no investment. And some of the best operating practices adapted in the melting that was given in detail in the report. So here the 8.11 lakhs energy cost saving and 96,516 units was saved. This three proposals comes under zero cost investment. This is why the zero cost investment 1,64,316. The same thing was here. So next one is a low cost investment. Energy efficiency measure in air compressor and the cogged wedge belt with the pulley change in short blast machine, impeller and dust collector. Already this belt area we touched up with the last webinar. So here there is a more wobbling is there. There is a more slippage is there. That's why the short blast machine timing is increased to 12 to 15 minutes per batch. Actually, it should be run around 5 to 7 minutes only. So the cogged belt and the pulley change means they are able to save almost 9,000 units per year, and the investment needed is 0.6 lakhs, and cost saving is 0.75 lakhs, and the payback period is 0.8 year. Energy efficiency measure means many energy efficiency measures we suggested in the air compressor. All put together, 27,000 units can be saved. For investing 1 lakh is needed. So 2.27 lakhs is the cost saving, and the 0.44 is here is the payback period. And the temperature controller based cooling tower. So once the temperature is reached based on the adiabatic controller, the fan can be switched off, so that 2,400 units can be saved in a year. And investment is 0.1, and the payback, the cost saving is 0.2. The payback is 0.5 years. And the turbo ventilator with the transparent sheet in the rooftop. In the rooftop, there is a fully sheets are covered, and the daytime also they are using many of the lights are used. Almost 80 to 90% of the installed lights are used for 24 hours. If the turbo ventilator with the transparent sheet is there, the natural light is entered into the foundry, and also the hot air is also evacuated from the foundry process. So they can be able to save 6,000 units, and 1.21 lakhs is the investment, and 0.5 lakhs is the saving. Almost 1.4 years is the payback period. And energy efficiency BLDC fans for wall mounting fans. Many Almanod fans are using 100 watts and 200 watts fans are there. It can be replaced with the brushless DC motor wall mounting fan. The unit can be saved almost 1,050 units. Similarly, for the furnace cooling pump also can be changed. So all put together, 6 proposals we are given in the low cost investment. So the unit saving is 54,450 units can be saved, and 4.22 lakhs is the investment, 4.55 lakhs is the cost saving, and the payback period is 1 year. For the medium cost investment, the compressor can be changed with 30 kilowatt energy efficient compressor with the VFD. The kilowatt saving is 29,400 units can be saved. 8 lakhs is the investment. 2.47 lakhs is the saving. So 3.2 years is the payback period. And there is a provision is there in the roof area, so that 90 kilowatt on-grid solar plant also we can suggest it. We suggested through the audit. So 90 kilowatt means 90 kilowatt into 5 days, 5 units per day. Per kilowatt into 300 days, it will give 1,35,000. 1,35,000 units can be generated. So this unit generation can be offset in the grid. So the investment cost is 18 lakhs and 11.3 lakhs is the benefit. So 1.6 years is the payback period for 90 kilowatt. So this two is very high cost investment, because about 2 lakhs is considered as a medium cost investment. So this is the trend chart of the power and fuel cost in the Foundry from December to January. So based on that, for production rate, the power and fuel cost is also varied. So this is the energy consumption profile. Melting is 73%. Normally the thumb rule says 70% in the melting, but this particular Foundry, 73% is gone for melting, and the air compressor is 6%. Sand plant, salt blast, and the cooling pumps for 12% is accounting. 2% for plant lighting, and the 7% for machine shop, because machine shop is also established in the same unit. So the liquid metal range is, the benchmarking is 630 to 650, but actually the unit was arrived around 765 units. So the difference is 115 units can be saved in the liquid metal. And the auxiliary also, the benchmarking is 160 to 180, but the unit is end up with 258. Here also 78 units can be saved. So based on the energy audit and the observations and outcome, the possible energy saving scopes from the existing Foundry process is 193 kilowatt per metric ton, because 115 plus 78, they put together 193 kWh per metric ton. So the average liquid metal production per year is almost 2,520 units. So the possible energy saving per year is 2520 into 193. It will give 4,86,360 units can be saved. That means 18.7% of energy can be saved. It is able to save by adapting the best practices, and all the measures was implemented as per our suggestions. So here the one more Foundry, they are doing some regular energy conservation activity in every year. So we are during our energy audit, we are not only pointing out the fault, because basically the energy auditing is not a fault finding report. It is also to be included the best practices and any measurements and any implementation is done for the last 1 year to 2 year period. We are also highlighted in the energy audit report also. Here, as per the BE rule and the PAT schemes, there are some 3 years data can be compared. So we taken 5 years ahead, because the Foundry unit is able to provide this kind of data. So based on that, 2018, 19, 20, 21, 22. So 20 is the lockdown period, COVID lockdown. So 21 is also almost some 3 months or some semi-lockdown. So 2018, we take it as a benchmarking. Here, the liquid metal, energy consumption is 123.83 lakhs units. LPG consumption is 500 kg, and HSD is almost 7958 liters. So equivalent MTOE is, that is the metric tonnage of oil equivalent, is 1075, and for liquid metal is 11,403 tons of liquid metal. So specific energy consumption in terms of kWh per metric ton is B, A divided by B. So A is 123.83908 lakhs units divided by 11,403. It gives 1,086.02 kWh per ton in the year of 2018. So every year they do some implementation in the energy conservation activity. They put efforts in the energy efficiency measures. They keep on reducing this specific energy consumption. 1,086 in the year 2018. In the year 1,011 and 20, 1,014 and 21, 991.65, and the year of 2022, 960. So per ton. So keep on reducing. So based on this, we can calculate. So the energy performance of the unit is 11.99% was reduced. That means 12% of the energy was saved in the year 2022 compared with the year of 2018. So based on the data collection, because the unit was given, so we are analyzing the best part also. So keep on implementing the energy conservation measures by the Foundry unit. So it will reflect the specific energy consumption also, so that the unit can save nearly 12% of the overall energy compared with the year 2018. In the year of 2020, they achieved 12%. And specific energy consumption is reduced to 960 units from the 1086. The energy savings per ton is also 125.86 units per ton and is equivalent to 11.59% from the reference year consumption. So far we are discussing some of the energy audit output and some of the energy conservation proposals given to the Foundry. So next one is, so the Tamil Nadu government was introducing a scheme called PEACE. PEACE means Promotion of Energy Audit and Conservation of Energy. So any MSME industry, the micro, small and medium industries, Foundry or any manufacturing industry, they can avail the energy audit. So they are able to reimburse 75% of the audit cost, or maximum of 1 lakh they can able to reimburse for the energy audit. And after audit, we are given some recommendations. No, based on the recommendation, if the unit is implementing the energy efficiency measure and energy conservation, energy efficiency technology, for the implementation cost, the capex cost, the unit can be able to reimburse 50% of the investment cost, or maximum of 10 lakhs rupees per unit. So this is the ceiling is given by the government of Tamil Nadu. So this scheme was running through the district industry center of all districts. So every districts they allotted for some industry energy audit. For example, Chennai, Chengalpattu and Kanchipuram, these areas are allotted for some 50 energy audits per year. And Coimbatore is also allotted for 40 to 50. Tirupur, some outside area like Tanjavur, Pudukkottai, these districts are allotted for 5 energy audits. So every year they allotted some 5 to 6 crores rupees for promotion of energy audit and conservation of energy for the MSME sector, to encouraging the unit for implementing the energy conservation measures and energy practices. So we are not in Coimbatore. So far we have conducted almost 15 energy audit under this PEACE scheme. So all the units was getting benefited, and the few units, 3 to 4 units was post implementation scheme applied, and they are also getting benefited around the 3 to 5 lakhs rupees they are gained for the implementation is also. Now we are focusing to the industry doing the energy audit under PEACE scheme, and also they are aiming for the 10 lakhs rupees per unit for the post implementations also. So these are the measures we taken in the Coimbatore Foundry cluster. So this is the one of the famous industry. So after this our energy audit, we have taken some appreciation letter. So this energy audit was conducted in the month of October under PEACE scheme. So 10 energy saving suggestions we are made, and 3,92,400 kg of LPG can be saved, and 4,42,150 of units of electricity can be saved. And this unit was received 1 lakh rupees in the PEACE scheme. So that's why the management was given, top management, the plant head of maintenance head was given appreciation letter to our team. So far we are seeing the what is the importance of energy audit in the foundry industry, and what is the benefit to the foundries. These are the topics so far we are seeing. So thank you for all the participants to listen the presentation patiently, and also thank the IIF Chennai chapter for giving me this opportunity for delivering this session.
Sir, it is a wonderful session, sir. Sir, any questions from the audience?
Sir, 2 minutes, sir. I will come, sir. 2 minutes.
Yeah.
Hello, sir. I am online, sir. Sir, any queries, questions, sir?
Not an issue, sir. Not an issue. Gentlemen, any specific queries? So in the chat, there is a question.
Hello.
Hello. Yeah.
Sir, if centrifugal compressor is useful
Sir, I would request you to introduce yourself and ask questions, sir.
This is Suresh Kumar from Consultant Coimbatore unit.
Okay.
Sir, having two questions regarding the compressor. Energy optimization is useful for us.
Hello.
Hello?
Hello, energy optimization for compressor.
Energy optimizer, that's IoT?
Yeah.
Yeah, tell me, sir, what is the doubt? Hello? Sir,
No,
in the
your
energy
question is
optimization,
whether energy optimizer is available or not. That's what is it your question?
It is available, but it is worth for energy saving.
the same IoT system, sir?
Yeah, energy saver, whether it is worth, that's what you were asking, whether it is
Sir,
commercially.
really it's very benefited, sir, because whether your present compressor system, how much CFM is generated or not, how do you know? Unless you have any monitoring system. See, you do some measures in the compressor systems. You do some practically some air leakages are arrested. Okay, what is the CFM and what is the air leakage CFM before and after? What is the unit consumption? All these things able to monitor with the help of IoT monitoring system.
Okay.
And also, so see, for example, in a foundry, they are having some 3 or 4 multiple air compressors there. One compressor is very, very low, very inefficient. By changing the air compressor with the new compressor, new technology, whether this system is there, no, you can able to identify how much CFM was generated in the existing system. What is the new CFM with the respective pressure? What is the energy consumption by the new energy compressor? A new compressor system, so that you are able to quantify the energy saving measures also. So you can able to demand with the supplier also. So you are committed this much CFM at the rate of this much pressure, but your compressor was generated only this X CFM at the rate of Y pressure. So you can able to argue.
Okay, sir. So another thing, we are using around 7,000 CFM to 8,000 CFM. So
okay, so it's a very large.
Go with centrifugal compressor.
Centrifugal compressor, sir. Centrifugal compressor means what is the application, sir, you are using?
For shooting pressure and general, sir. It's a normal.
Oh, normal foundry operations only, no?
Yeah.
Yeah, better you go with the screw compressor with the IPM model.
Already we are having screw compressor only, sir.
Okay, sir. Okay. Any IPM model is there, sir? Internal permanent magnet motor?
No, sir.
Because
No,
the
sir.
motor efficiency is 95% above. If it is possible to replace, see, first thing is always you do some basic, some energy efficiency measure like pressure optimization and any air ducting is there. So the ventilation air, no, hot air ventilator. You can provide aluminum ducting for the air compressor. So the hot air will be going out, and also your air inlet filter to be cleaned, and the pressure optimization, air leakages, all these small things are we can implement.
We are having air duct and also.
Yeah, so by adapting the best operating practices and all the routine checking kind air leakages and other things, then you decide about the new compressor whether it is needed or not.
Because we are using around 15 years.
Okay.
Old.
Okay.
So
in that case, 7,000 8,000 CFM means what is the kilowatt capacity of the compressor?
Each compressor is 1,000 CFM, 160 kilowatts.
Yeah, 160 kilowatt. That means 160 kilowatt into 8 numbers you have. So you have any common distribution system only, no? Or any multiple section wise it is going means you can adapting this IoT system. It is able to install up to 8 or 16 because basically it's a digital systems, no? Binary value only they are taken. So you can able to put multiple sensors or flow sensors, and you can integrate it with the common system. So master slave kind of things you can able to operate, so that you can visualize what is the kilowatt consumption and what is the CFM generation from the air compressor for the yesterday's production. So you can relate with your production value also, how much tons you are produced.
Okay.
So for monitoring and observation and analyzing part, So without monitoring and analyzing, we cannot able to do any energy saving measures. For that, this tool is very important.
Okay. Okay, sir. Thank you.
Okay, thank you, sir.
So in the chat, there is a gentleman from the name of Dinesh. He said only related for air audit, anything related to paint shop or induction auditing. The speaker has to spend a lot of time on that, sir. He has already spent the time. Any other questions? Sunny Sabarwal, sir. Sunny Sabarwal, sir, use some Hindi language, sir. Sorry, unfortunately, it is for national level, and most of South Indians are comfortable in English. That is why.
Webinar 5 minutes.
Sir, I have a question.
Yeah, hello, sir. Tell me, sir.
Yeah. This peace program which you have explained, no, it looks very attractive.
Yes,
But
sir.
how many people are because I'm sure that I think MSME is not much aware of it. See where I could see your presentation, the way of audit. There are so many things, even with zero cost investment, there are so many improvements can be done.
Yes, sir.
And for that, they are also taking care of the charges. Then the implementation also certain amount of money is being taken care.
Yes, sir.
And how it is penetrated? How what is that? Any
Sir,
data
in Coimbatore, we are penetrated, sir, in the foundry sector. Okay, but whereas even the district industries, GM is also regularly called me. So you do more audit. We are having fund and other things. But the only thing is still some awareness is not happened in the sector. So the eligibility is only MSME. So you have Udayam registration number. Under this Udayam registration number, your company belongs to micro, small, or medium, any one category. That's all. So based on the energy audit, no, you can able to reimburse. So for example, if you are doing 1 lakh rupee for energy audit, you can able to claim 75%. That is 75,000 rupees you are getting reimbursed for the energy auditing itself. After this energy auditing, based on the recommendation given by the energy auditing team, you may implement some 3 or 4 only. But normally we give 10 or 12. But all proposals was not able to implement by the unit because of the financial position and other market positions also. So suppose you adapted some 3 or 4 implementation at the cost of some 8 lakhs rupees you are invested, and 8 lakhs rupees. And another thing is in the peace scheme, you should save some energy, okay, for adapting this kind of energy efficiency method, no? You should quantify some kind of energy up to 5 to 10% of energy to be reduced, so that such a way you can document, and maybe we are re-auditing after the implementation, we will give a report how much energy you have saved. So based on that, you can apply, because everything is the online only, okay? It's an online portal is there, so all the documents to be uploaded. Moment all these things are documents uploaded, everything was viewed by the MSME headquarters Chennai. So all these things was scrutinized by the respective people. Then they are given the funding. Based on the funding position, the implementation cost is also given. So see, normally in the peace scheme, no, every year, the financial year, April to June, the first quarter, the fund position is not there, because all the formalities is to be completed by the state government, and the amount was given to all the DACs at the month of June or July only. Okay, July. So after July, some sufficient fund is there. So it's a priority level. If all the documents, everything is pakka, then the DAC was releasing the payment. All are online only in the bank transaction only.
Oh, that means you are for the even consultancy. What is it for auditor? Like it is not after audit, it is not given. Only after showing the improvements, this will be given. Is it, or is only for the
no, sir. For audit, once the audit is completed, you can be able to upload the peace audit. Okay, energy audit. So in that you can provide the document, like so first we give the purchase offer, no. Based on that you are given the purchase order. Then we will give a detailed energy audit report, and also your bank statement to the auditing firm, your transaction, the amount, no, that the details, all these details to be included along with this kind of Udayam registration number, and whether the company is a partnership company or LLP or any board of director related thing, and the EB card. This some data they needed. All these things are uploaded 200 KB level PDF format in the website, online web portal. The same thing, the hard copy to be given to the respective section of the DAC, sir. That's all. So for auditing, you can able to get maximum 1 lakh. That means if you are doing 1.35 lakhs rupees audit means you can get 1 lakh rupees is the maximum ceiling.
Yeah, I understood.
So here the GST to be paid. So GST paid company energy auditing firm only eligible here. Okay. So this 1 lakh means 1 lakh plus GST. That is the meaning.
Okay. Only for the implementation, you are saying that energy improvement has to be shown.
Yeah, some energy improvements should be shown. Due to this shifting of this technology, you can save some energy. So I am saving this kind of. So ultimately, the CO2 emission reduction, sir. Everything was all the schemes implemented by the government, bilateral or any national, international agencies are coming with the funding project. Now already I am working with the UNDP Deloitte project for the steel sector, mini steel sector, for the low carbon implementation. So it is a purely Japanese fund. So it will be implemented in India around 120 units across 4 clusters. One is Punjab, one is Ahmedabad and Raipur, and one is Coimbatore and Palakkad. So we are doing the baseline energy audit at the free of cost. Okay, all the measurements we are doing the free of cost, because as a consultant, the Deloitte was given the payment to us because they are taking the order. So for the implementation also, this UNDP was given some financial incentive to the each and every unit, some certain portion that was decided by one of the leading institute in the Punjab. So there will decide. So the ultimate aim of the project is this much CO2 emissions was eliminated. This is the ultimate aim.
That's great, sir.
And many corporate industries now, they are seeking their own carbon footprint. What is their carbon footprint? So that is the need of the hour.
Yeah. But you say number of maybe some 40 audits or 50 audits. That data is available online, sir, or how it is?
No, sir. See, normally these energy audits are purely confidential, sir. Okay. Between audit company and between us only. Okay, these data are not.
But not data, sir. You are saying that piece under piece scheme. You are saying the Chennai Chengalpattu, you are saying about 40 audits. There are some limitations.
Yeah, see, that is available in the MSME online portal also. MSME online tn.gov.in. You can go through it now.
Generally, it is fully utilized or not utilized, sir?
See, some cities it was utilized, sir, but even in Coimbatore is also not much penetrated because we have started in the year 2019 only. After that, there is a major lockdown is there. So far we are pushed up to 15 units we are completed and all the units are getting reimbursed. Amount was getting.
Yeah, you will be able to support the MSMEs, even including the filing of the documents to the portal and things like that.
That is the basic thing, sir. Whatever the things we needed, from our side, we are given all the documents, and also from the unit side, what are the documents to be made ready? We are also guiding us. So
guide them. That's what you give the guidance so that they will be able to upload.
Yeah. So uploading is hardly, it takes only 5 minutes. You can create your own user ID and password. After that, this all supporting documents to be less than 200 KB of PDF format only. Okay. Once all the things are uploaded, you can get the acknowledgement copy. So you can take the printout and sign it. And once you load it in the online portal, all the things are recorded. Okay. So the department wise, section wise, they are able to scrutinize the thing.
Oh, that's great.
So we are given the detailed energy audit report, 2 books, sir. One is for unit, and another book is purely for the DIC submission for peace scheme. So you are submitting all the documents along with the peace energy audit report. You have to submit to the DIC. Then, based on the queuing level and the priority, once your turn is come, your reimbursement amount will be directly transferred to your account, bank account.
Okay, that's right. Thank you, sir. Thank you. Any question, gentlemen? We are already reached 4:18. Sir, we'll discuss offline. I have some queries. Maybe I think we can take it up bigger level to our maybe our Chennai MSMEs. Okay. You should help us, sir.
Yes, sir. Definitely, sir.
Yeah, I think it looks because see, in fact, I could not attend your last seminar because I was traveling, and I think I just opened up, but I felt it is one of the lot of possibilities of cost saving, and the investment. What you are saying is very less. People should make use of it. I think, as you rightly said, awareness is not there. That we have to ensure that it's reaching them, sir.
Yes, sir. Yes, sir. Definitely. That's why I told last time itself, we can make a separate session for this awareness of energy audit. That's why I lastly introduced this P scheme. Still, many industries are not knowing about the scheme.
Yeah, yeah. So it is like, no, for their own improvement, they are investing, but for that, government is also supporting.
Yeah, already government is given some subsidy. Why not we can utilize the same?
Utilize it, yes.
See, only thing is you can find out the right auditing teams because mostly during this government kind of subsidy scheme, no, if the quality of the audit is not clearly known, means there is no useful. That is the thing.
Yeah. No, this is for getting the subsidy from the government should be only as a second priority.
Yeah, second
Main
only.
priority should be the actual implementation, so that
So the intention is they have to know their own level. What is their level energy performance? That is the main motive.
Yes, that's true. Yama Prasad sir, are you there?
Yes, sir. Yes, sir.
Yeah. Okay, now I would request our council member, Mr. Yama Prasad, to give out of thanks, please.
Thank you, Dr. Sivakumar, to give a detailed presentation on the energy auditing. I hope all the participants are getting this knowledge about this energy auditing. So please try to implement this in your organization. If Dr. Sivakumar sir gave your mobile number and mail ID, if you have any queries, you can contact him also. So once again, thank you for all the participants and Dr. Sivakumar. Thank you, sir.
Okay. Thank you, sir.
Thank you, sir. Thank you, participant. I would rather recommend you to take use of Sivakumar sir support, these services. I think that would benefit you as a company. Thank you very much. Thank you all. Thank you. Thank you very much.
Thank you all,
sir.
sir.
Thank you, sir. Thank you.